to demonstrate how to calculate a gear ratio from a planetary gear set. And just to begin, let's make sure that we understand how to calculate gear ratios in general. The formula that we use for a gear ratio is the number of teeth on the driven gear over the number of teeth on the drive gear. So, for example, if I had a small gear that had 10 teeth on it, that was turning a larger gear that had 40 teeth on it. This is the drive gear. This is the gear that's being driven. And so we would say 40 over 10 or 4 for a 4-to-1 gear ratio. What that means is the drive gear has to turn 4 times in order to turn the driven gear once. And that's where the 4-to-1 gear ratio comes from. So it affects the speed and the torque. Of course, the speed of this gear will be 1/4 the speed of this gear, but the torque at this gear will be 4 times greater than the torque at this gear. So it's a trade-off between speed and torque. Now let's see how we do that with a planetary gear set. Of course, a planetary gear set has 3 members. There's a sun gear in the center, there's a planetary carrier in the middle, and they're surrounded by a ring gear. Pull that apart so you can see the 3 individual components. Again, the sun gear, the ring gear, and then the planetary carrier here that has the planetary pinions on it. Now, the way that a planetary gear set is typically used is that one of those 3 members is held stationary while one is turned. So you have an input and an output, and then one that's held stationary. So, for example, if I hold, let's do it this way, if I hold the ring gear stationary and turn the sun gear, there's a gear ratio there. This is the drive gear, the one that's doing the turning. This is the one that's being turned, right? So the drive and the driven gear. And I could do that. I could just change the combination any way I wanted to. I could hold this still while I turn this, hold the sun gear and turn the ring gear. Now the ring gear is the drive gear and the carrier is the driven gear. You can do that in many different combinations. But here's how you calculate this. So we would need to take each of these gears and count the number of teeth. So on the sun gear, we'd want to mark it and then count the number of teeth. Now let's just say, for the sake of the example, that I counted 30 teeth on the sun. I would take the ring gear and count the number of teeth on it. Let's say that I counted 90 teeth. And then finally, I would take this gear, but I won't count the teeth on it. First of all, you couldn't. There could be varying numbers of pinions on this gear, and it doesn't matter how many teeth there are on the pinions. What I'll do is I'll say that the planetary carrier is equal to the sum of the sun and the ring gear. So that's 120. So that's the secret here, is we don't actually count the teeth on the carrier. We calculate it based on the sum of the other 2 gears. So now I put that back together. Now I can choose any combination of this planetary gear set. I can hold the ring gear stationary, and I can turn the carrier. It makes the carrier the drive gear, and what's the driven gear? The sun gear is the driven gear. So the driven gear is the sun. It has 30 teeth. The drive is the carrier. And when I calculate that, I get 1/4, which equals 0.25 to 1. And that's the gear ratio when I do it that way. So that's an overdrive gear ratio. If I wanted to give you one more example, let's say that we are going to hold the carrier stationary, and I will turn the sun gear. You can see that is reversed. The ring gear is going in the opposite direction. But now the drive gear is the sun gear. The driven gear is the ring gear. So driven is the ring gear, which is 90. Drive gear is the sun gear, which is 30. which equals 3, or a 3 to 1 gear ratio. So the sun gear would have to turn 3 times for the ring gear to turn once. That's how you calculate a gear ratio on a planetary gear set.